ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಗಳಾದಂಥ ಡಾಕ್ಟರ್ ಬಿ ಪರ್ವತಲು ಹಾಗೂ ಜೊತೆಗೆ ಅಧ್ಯಕ್ಷತೆ ವಹಿಸಿದಂಥ ಸುರೇಶ್ ಗಾಂಧಿ ದಯವಿಟ್ಟು ಮಾತೃಕೆಗಳು ಮತ್ತು ನೀತಿಯಂತೆ ಇಂದಿನ ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಗಳಾಗಿ ಗಣಿತಶಾಸ್ತ್ರ ವಿಭಾಗದ ಮುಖ್ಯಸ್ಥರು ಸಹ ಪ್ರಾಧ್ಯಾಪಕರು ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮಹಾವಿದ್ಯಾಲಯ ಡಾಕ್ಟರ್ ಬಿ ಪರ್ವತಲು ಆಗಮಿಸಿದ್ದಾರೆ. ತಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ತುಂಬ ಹೃದಯದ ಸ್ವಾಗತವನ್ನು ಕೋರ್ತೀನಿ. ಅವರಿಗೆ ಈ ಹಬ್ಬರವರು ಪುಷ್ಪಗುಚ್ಛ ನೀಡಿದ್ದು. ಅದೇ ರೀತಿ ಇಂದಿನ ಈ ಗೋಷ್ಠಿಯ ಅಧ್ಯಕ್ಷತೆಯನ್ನು ವಹಿಸಿರುವಂಥ ಡಾಕ್ಟರ್ ಸುರೇಶ್ ಗಾಂಧಿ ಸಹಾಯಕ ಪ್ರಾಧ್ಯಾಪಕರು ವಿಠಲ್ ಮಹಾವಿದ್ಯಾಲಯ ಧಾರವಾಡ, ಇವರಿಗೂ ಸಹ ತುಂಬ ಹೃದಯದ ಸ್ವಾಗತವನ್ನು ಈ ಸಂದರ್ಭದಲ್ಲಿ ಬಯಸ್ತೇನೆ. ಇವರಿಗೆ ಡಾಕ್ಟರ್ ಮಂಕಮ್ ಅವರು ಪುಷ್ಪಗುಚ್ಛ ನೀಡಬೇಕಂತ ಈಗ ಗೋಷ್ಠಿ ಪ್ರಾರಂಭ ಆಗುತ್ತೆ. ಈ ಮುಖ್ಯ ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಗಳಾಗಿ ಆಗಮಿಸಿರುವಂಥ ಡಾಕ್ಟರ್ ಬಿ ಪರ್ವತಲು ಇವರ ಒಂದು ಸಣ್ಣ ಕಿರು ಪರಿಚಯವನ್ನು ಡಾಕ್ಟರ್ ಅನುಕೂಲ ಮೇಡಮ್ ಮಾಡ್ತಾರೆ.
ಈ ಒಂದು ಸೆಷನ್ಗೆ ನಾನು ಇಂಟೆನ್ಷನಲಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಇಂದ ಕರೆದಿರೋಲ್ಲ. ನಮಗೆ ಆ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಅವರು ಯಾವ ಥರ ಆ ಲೊಕೇಶನ್ಸ್ಗಳನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಮತ್ತು ಯಾವ ಥರದ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅನ್ನೋದು ನಮಗೆ ವೆರಿ ವೆರಿ ಅಂತ ಬೇಕು. ಸೊ ಉಳಿದೆಲ್ಲ ಪರ್ಸನ್ಸ್ಗಳು ನಮ್ಮ ಎಕನಾಮಿಕ್ಸ್ ಫ್ಯಾಮಿಲಿಯಲ್ಲೇ ಇದ್ರು. ಸೊ ಹಾಗಾಗಿ ಅಲ್ಲಿ ನಾವು ಜಾಸ್ತಿ ಇಂಟ್ರೊಡಕ್ಷನ್ ಮೇಲೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕೊಡಲಿಲ್ಲ. ಬಟ್ ದಿಸ್ ಪರ್ಸನ್ ಅವರು ನಮಗೆ ಹಿಸ್ಟ್ರಿ ಕಮಿಂಗ್. So he has done his BSc from Osmania University in 2006, Master of Science in Applied Mathematics from Hyderabad Central University, Master of Technology in Systems Analysis and Computer Applications from National Institute of Technology, Karnataka, Surat in the year 2010. Further from the same in the year 2022, just in last month, he completed his PhD. When we take up his teaching experience, he worked as lecturer in the Department of Mathematical and Computational Sciences in the National Institute of Technology, Karnataka, Surat from 2010 to 2012. Then afterwards, he joined our college, and since 2012 till date, he is working in our college. Just last month he has taken the headship of the Department of Mathematics. The courses that he has taught is from PUC to PG, post-graduation. Areas of specific research are pattern graph theory, trade theory. Awards and distinctions. He has secured All India 82nd rank. All India 82nd rank in CSIR UGC Net Mathematics in the year June 2011. He secured All India 404th rank in GATE. In GATE, he secured 404th rank in the year 2008 in mathematics. Then he secured All India 183rd rank in JEST in 2011 in computer science. So the development that he has attended so many development programs. Then further he has attended 17 conference presentations, 4 STC and many STC and workshops. Then at present he is supervising 9 students under him for a dissertation work, research contributions. When we take up publications published, the total number of publications in international reputed journals is 18. That includes 3 in Springer, 1 in Elsewhere, and 2 with more than 2.5 impact factor. So he is the membership. He has the membership of professional bodies like life member of the Indian Science Congress Association (ISCA), then life member of the International Association of Engineers. So from IQAC coordinator to the IT coordinator, there are so many responsibilities. He is heading at this young age. Further, along with this mathematical expertise, even he has technical skills in programming computing languages like C, C++, Java, JavaScript, MATLAB, Sage, ScienceLab, Maxima, and LaTeX. Then OS Familiar, Linux, then Windows, Tools and Technologies, that is HTML, JSP, XML, SQL Server 2005, database technologies, that is Oracle, and there are so many other technical skills. So from the 2012 batch, actually we had our college has system which we consider gems of our college. We had 3 gems. 2012 batch ಅಲ್ಲಿ ನಮ್ಮ ಕಾಲೇಜ್ ಗೆ 3 ಮುತ್ತುಗಳು ಜಾಯಿನ್ ಆಗಿದ್ದು ಒಂದು ಬಹಳ ಬೇರೆ ಫ್ರೀ ಆಗಿತ್ತು. ಬಟ್ ಇನ್ನು 2 ಮುತ್ತುಗಳಂತೂ ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಇದೆ. ಇವು ಇದೇ ತರ ಬೆಳೀತಾ ಇದ್ದಾರೆ ಅಂತ ಅನ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. ಸೊ ನಮ್ಮ ಮುಂದಿನ ಕಾಲೇಜಿನ ಭವಿಷ್ಯಗಳು. ಸೊ ಐ ವೆಲ್ಕಮ್ ಯು ಹೋಲ್ ಹಾರ್ಟೆಡ್ಲಿ ಫ್ರಮ್ ಅವರ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್. ಅಂಡ್ ಎಕನಾಮಿಕ್ಸ್ ಸಂಬಂಧಪಟ್ಟ ಹಾಗೆ ನಮ್ಮ ಕೆಸಿಡಿಲಿ ಮಾತ್ರ ಯಾವಾಗಲೂ ಸಹಿತ ನಾವು PUC ಅಲ್ಲ BA ಒಳಗಡೆ ಎಕನಾಮಿಕ್ಸ್ ಆಪ್ಷನ್ ಇಟ್ಟಿದ್ದೀವಿ, ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಆಪ್ಷನ್ ಇಟ್ಟಿದ್ದೀವಿ. ನಮ್ಮಲ್ಲಿ ಎಕನಾಮಿಕ್ಸ್, ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕ್ಸ್ ಮತ್ತು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಆಪ್ಷನ್ ಇದೆ. ಸೊ ಹಾಗಾಗಿ ಎಕನಾಮಿಕ್ಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಗಳಿಗೆ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅನ್ನು ಕಲಿಸುವಂತ ಅನುಭವ ನಮ್ಮ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಫ್ಯಾಕಲ್ಟಿ ಮೆಂಬರ್ಸ್ ಗಳಿಗೆ. ಸೊ ಹಿ ಇಸ್ ಟೇಕಿಂಗ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಟಾಪಿಕ್. ಸೊ ನೌ ಐ ರಿಕ್ವೆಸ್ಟ್ Parvatalu to take over.
Good afternoon, everyone. At the outset, let me thank Dr. Annapurna Madam and Dr. Ramappa sir for giving this opportunity to share my little knowledge with you. And also I thank the principal of Karnataka College. So today I am going to cover 2 units which were assigned to me, matrices and the limits. And maybe within 1 hour it may not be easy to cover the 2 units, but possibly I will try my best to cover all the names or the concepts which were given in the syllabus. So today I am going to cover the 2 units. These two units I am going to cover. So let me start with matrices. So now, as you are already familiar with matrices, and I am not going to spend much time on that, but let me give the definition, and later on we may discuss the different kind of things. So it is usually you can say a set of elements. So organized into rows and columns. So this maybe is little definition about the matrix. So it is set of elements. Set of elements can be linear. So as usual, how we take in real world, even including fractions, decimals, and whatever the numbers usually, and most of the numbers that you may use are the real numbers, the possible numbers that may occur in our day-to-day life. So therefore now we are taking some set of elements and organizing into rows and columns. And maybe you may find the different kind of definitions in different things, like rectangular arrangements of rows and columns. But whatever it may be, it is just arrangement of the numbers in rows as well as columns. So that is what we mean by matrix. So for example, what is it? Some numbers. For convenience, I am taking the numbers 1, 2, 3 and 4. So now this is a one simple matrix which has 2 rows, and usually we write here to represent its dimensions and a number of columns. So here we have 2. So now we can say this dimension of this matrix, or maybe order sometimes we can even we may use even size also. So size is nothing but the number of rows by number of columns. So this is the matrix with the size 2 by 2. So usually it is very convenient, and for many of our courses in mathematics, usually these matrices we represent with positions. So to avoid the confusion, so we represent with the positions. I mean, so if you have a 2 by 2 matrix, so we can represent with some elements, like this subscript 1 comma 1 represents first row, first column element, and here 1 2 represents this is the element in the first row and second. So therefore it is very convenient to represent the elements in the matrix. So now with this convenient notation, we can understand easily like matrix addition, subtraction, multiplication, or maybe scalar multiplication to the matrix also. So therefore now let us move into the type of matrices. So the next the concept may be the types of matrices. So now let us discuss the types of matrices. So there are different kind of arrangements. There are different kind of arrangements. Based on the special kind of arrangements, we give the name for that. So therefore, first of such kind of arrangement, suppose if you have the elements in the matrix in only the single row, like A11, A12, A13. So now I have 3 elements, and these are all real numbers. Whatever I, A, I, J I take, they are real numbers. Whatever the numbers I take in the matrix, they are real numbers. Okay. So now we have only one row, so we call it as row matrix. Or if you have only one column, if you have only one column, A11, A21, A31. So this is the matrix. This is our matrix. So here the dimension of this matrix is 1 by 3, and dimension of this matrix is 3 by 1. So we have 3 rows, 1 column. Okay. So this is column matrix. And usually instead of saying row matrix or column matrix, sometimes these together we call it as vector. So we call it as a vector. So therefore this is one type of matrix, either row matrix or column matrix. But also we may have other kind of matrices, the diagonal matrix. So the diagonal matrix, in the sense in the name itself we have the diagonal. So we are giving the importance to the diagonal. So therefore only take the elements in the diagonal, possibly non-zero elements, and remaining are 0. Remaining are 0. So that means you may have these elements, diagonal elements. First, first row first column element, second row second column element, third row third column element, and taking remaining 0. And this can be any numbers. Those can be any numbers, but they are just real numbers. So you can take any numbers. So suppose if I can take here 1, 2, 3, etc. So it is a diagonal. Okay, so that means we are giving preference to the only diagonal elements, and remaining are 0. So therefore we call it as a diagonal matrix. And if the diagonal matrix has all equal elements, okay, so this particular type of matrix we call it as a scalar matrix. So this is another type. So if all the elements in the diagonal, if they are equal, so we call it as a scalar matrix. And another very particular type, if we have only one in the diagonal, so this we call it as the identity matrix. So therefore, there are three names for diagonal matrix. The general is diagonal. If all the elements are equal, it is scalar. And if all the elements are equal and equals to 1, we call it as the identity matrix. So therefore, these are some different kind of. Suppose there is another diagonal matrix. There is another diagonal matrix. Suppose if I take R0. So this is also diagonal matrix. So this we call it as a null matrix. There is nothing in the elements except 0. So we call it as null. So there is no non-zero element in the matrix. So we call it as a null matrix. So therefore, these are some different type of matrices we have in the matrices. And so let us move into the, and of course I might be forgetting, but there are some other kind of types. Like suppose if you take some non-zero elements only in the upper diagonal. If you take only non-zero elements in the above the diagonal, upper diagonal elements, so we call it as a upper diagonal matrix. This is also diagonal matrix, but it is upper diagonal matrix. And similarly, suppose if you take all elements 0 which lies above the diagonal, and below the diagonal some of them is non-zero. So this is usually, so once we have upper means this is usually called lower. And of course here in the diagonal whatever the elements you have doesn't matter. So you can have any number of elements, need not be 0 here. So it's need not be 0, so you may have any elements. So to say any element, I am writing A11, A22 and A3. So diagonal doesn't matter, but only above the diagonal if the elements are non-zero, and below the diagonal if they are 0, then it is called upper triangular or upper diagonal. So upper diagonal, upper triangular also. And similarly, if the below the diagonal elements are non-zero and above diagonal elements are 0, so we call it as the lowest. This is actually lowest. So lower triangular matrix or lower diagonal matrix. So these are the some types of matrices we have in the matrices. So now let us look at the operations. So that means algebra of matrices. So what kind of manipulations we can do by using the matrices. So that means this is just like arrangements. So if you have the similar kind of arrangements, is it possible to add? The general way of thinking. Suppose if you take two numbers, so usually we add. If you take 2 and 3, so we add them, so we get 5. And similarly, these arrangements, these are just arrangements. So you have two kinds of arrangement. So is it possible to add them? or is it possible to subtract? Is it possible to multiply? So therefore these are the common things which arises in mathematics or even in general also. Okay. So therefore now if you have two different kind of matrices. So now let me take two matrices A11. So let us say this is one matrix A, and usually the matrices are represented by capital letters, and the elements in the matrix are usually denoted with the lower letters. So now let me take another matrix B, B11, B12, B21, B2. So now you see, we can observe there is a similar structure in both. So there is a similar structure. That means here you have 2 by 2 matrix, and here also you have 2 by 2 matrix. So now, is that possible to add? So the general way of thinking, so you have these two similar structures. So now is that possible to add? So therefore, yes, we can add. So whenever there is similar structure, so that means this order must match in order to add. So therefore, addition of matrices we can take. So that means, so here we can take addition. Yes. So addition of matrices, it is done by with respect to positions. So these positions are met. So A11, B1, A12, B1, A21, B21. So that means you need to add the corresponding elements in both matrices. So this is the addition of matrices. And similarly, you can take subtraction also. So these are just like the usual numbers. Whatever we are doing here is the usual operations how we do with respect to the real numbers. But here we have the arrangement, the same we are doing. Only the positions we are taking. That's all. The positions are there. So therefore, if we can take here, so the same thing maybe with this negative symbol. The elements are same. So elements are same here. So now this is a possible subtraction between two matrices. And also you can multiply a scalar to the matrix. So that means suppose I have a scalar. Let us say k. K is some scalar, it is some real number. Suppose if I want to multiply to a. Okay. So if you have usually two numbers, if you wish to multiply, we will usually multiply. So you have some arrangement, you want to multiply. So that means you need to multiply to each and every element. So therefore, that's what we do. So we have here A11, A12, A21, A22. So therefore, multiply this k to each and every element. So this is scalar multiplication. So you are multiplying by a scalar. So we call it as scalar multiplication. So you are multiplying by a real number. So now addition, subtraction we have done, but multiplication. So multiplication, it is defined differently. And of course you can do the corresponding positions. You can take the corresponding position and multiply the elements. But instead of that, we have here different kind of multiplication. And suppose they are the both matrices. So the multiplication usually we will write with this cross symbol. So now, so we may have some, let us say, some resultant matrix. So this is the resultant matrix we are expecting. So now in this resultant matrix, you can see again these suffixes 1 1. So how that R11 is obtained? It is obtained by taking the first here R11 means this one represents rows. Okay, and this one represents columns. So now you take this is first row. So that means you take this first row. And this is first column. And take first one. But it is second entry. Second entry means you should go to the second matrix. So therefore you take first column.
Can you take one numerical example for us?
No?
Numerical example.
Numerical. Yes, I will. So therefore now see this is something like we are taking to A11, A12, B11 and B21. So now you do the usual multiplication now. Do the usual multiplication. That means you take first element here, and second element here and second element here. Okay, so therefore add together A11, B11 and A12, B21. So again it comes into the usual multiplication. But the way we multiply is different. That is what I am saying. The way we multiply is different, but finally it comes to the usual multiplication. So that means, so now let us take one simple example. 1, 2, 3, 4. 5, 6, 7, 8. Okay. So now, if you wish to multiply this, so now you are getting this is the position is first row, first column. So first row you need to take here, and first column you need to take here. So that means 1 into 5 and 2 into 7. Okay. But when you pick up this separately, usual multiplication we do. Like corresponding positions only. We take the corresponding, what I am saying, so instead of writing this, as I already said, they are the vectors, either row or column, they are the vectors. So now we can arrange this like row only. So now you see, I am arranging this, I am taking this first row in the first matrix, first column in the second matrix. I am writing like row wise only. But what I am doing multiplication, the corresponding elements. That takes up. Okay. So therefore, it is that again it will turn into the usual multiplication. Okay. And similarly, suppose I want this resultant element R12. So now I need to take first row because this entry is 1. So now second here 2. But this 2 corresponding to the column. So in the second matrix, second column. So again, usual multiplication with sum. So therefore, now this second entry, it can be obtained by multiplying first row in the first matrix, second column in the second matrix. So I will get this. So 1 into 6, 2 into 8. Okay. So this is how we do the matrix. I hope that is clear, the matrix multiplication. Okay. So now, similarly here, suppose if I want to get this element, resultant element, what I should do? Take the second row in the first matrix, first column into the second matrix. Suppose if I wanted this second row in the first matrix, second column into the second matrix. So multiply, use row multiplication with sum. So that gives the resultant matrix. So that is the multiplication of the matrix. Suppose if you can have one simple example, and of course I come with one simple example for multiplication. Let us look at it. Let us say there are 2 or 3 firms or maybe factories, factory 1 and factory 2 and factory 3. Okay. And let us look at the manufacturing products, that is total number of products. Maybe I am moving little fast because time will not be sufficient. Suppose if I take the months August, maybe September and October. So now let us look at the factory one, the total number of products that can produce in August one month. Let us say maybe some 1,000 units it produces, and maybe some 2,000 units in the September month, and maybe some 1,500 in the October month. Okay. And similarly factory 2, maybe let us say 1,200, 1,100 and maybe 1,300. Maybe factory 3, 1,100, 1,200 and 1,300. So now we have one simple example, and there are 3 factories, and in 3 months they produces this number of units. So that means factory 1 in August month, so it produces 1,000 units, and factory 1 in September month produces 2,000 units. So here what is our task? So for any production there is a defective rate. Okay. So whatever the products you take, so we may not expect 100% right now. So therefore there may be some failure rate. So let us say for factory 1 and factory 2, factory 3. So we have some failure percentage. Let us say it is 2%, 3%, or maybe 1%. So now here the question is, so find total number of defective units in each month. So total number of defective units in each month. Okay. So now let us try to use matrix multiplication, as we have discussed just now, matrix multiplication, and usually we do this. So how we usually do? Suppose if I wish to find in August month total number of defective units, what we should do? So take 2% of this, 3% of this, and 1% of this, then add it. Then add it together, so you will get total number of defective units in August month. Similarly here. Okay. So now take 2% and factory 2 has 3%, take 3% of 1,100, take 1% of 1,200, then add together, so you will get total number of defective units in September. So therefore, so in matrix multiplication, how we can do? So therefore, what we have to do? So put this into the matrix. Put this into the matrix. So in August month, first factory should match, second factory percentage failure rate, and third factory failure rate, it should match. So that means what we should do in the matrix multiplication, what we do? We take rows into the first matrix and columns into the second matrix usually. So that means this should come into the row. So that means what we need to do, here we have column arranged into the rows. So therefore we have 1,000 here, 1,200, 1,100, and 2,000, 1,100, 1,200, 1,500, 1,300, 1,300, and this you need to multiply with this respective defective percentage. So that means 2% means out of 100 it is 0.0, and 3% out of 100 it is 0.02, and 1% out of 100 is. So now if you can multiply this, you will get the total number of defects in each month. In each month. So that means this matrix multiplication gives. So now we may get here only row vector. So multiply here. So how much is it? 1,000 into 0.2. So you get 40. And 1,200 into this 36. And 1,100 into this 11. we need to multiply, matrix multiplication. That means the bigger the matrix will get it. 1000 into 0.02 first from first term. 1200 into 0.03, 1100 into 0. This is first element. This is first element. Okay. And similarly, second element. Second element is what? So now second row, first term, second element. So 2000 into 0.0002, 1100 into 503 plus 1200 into 501. This is second element. And third element. Third element is 1500 into 0.02 plus 1300 into 0.03 plus 1300 into 0.0. So this is what you get. Of course, here what is the dimension? So we have here 3 rows and 3 columns, and here 3 rows and 1 column. So therefore, matrix multiplication is possible whenever you have the total number of columns in the first matrix and the total number of rows in the second matrix. If that matches, then the matrix multiplication is possible. So therefore, here you get 3 by 1 matrix. That means you get a column matrix. So you get a column. So therefore, so here how much you get? So that is the total number of defectives in the August month for all those factors. And whatever the element you get here, that is the total number of defectives in September, and so on. So therefore, this is one simple example to find out the total number of defective units for each month. So by matrix multiplication. And usually you can do in general. Like what you need to do? Take 2% of this, 3% of this, and 1% of this, add together. So that you get in the August. So therefore, this may be one simple example. So to use the matrix multiplication in general. I hope this is clear. The matrix multiplication. And similarly, so we have the determinants. So I am moving little fast because I need to cover 2 units. For one limited definition itself I take 1 hour. Usually in my regular class, for only one limited definition I take 1 hour. So it's highly impossible to cover within 1 hour all these concepts. So therefore I am moving little fast. So hope you try to adjust to me. Okay. So now the determinant. So here, suppose if you have a matrix A, so determinant of matrix is nothing but the transpose of cofactor matrix.
Parvatalu, till you can continue till the second session. Today's is your soul.
Second session.
You can be a little bit slow.
Sure. But make sure that you should not explain. Okay. So now transpose of it. Transpose I didn't say. Okay. I must say first transpose, then let us move into the determinant. So transpose of a matrix is nothing but the rows are arranged into the columns and columns are arranged into the rows. So that is the transpose of matrix. So what is the transpose? So you may have a matrix. Let us say A. So you have the elements. So now in order to find the transpose, what you need to do? You need to transpose. Transpose the elements. Transpose the elements here meaning, so rows should arrange into the columns. And this the rows, and once you arrange into the rows into the columns, automatically columns are transposed into the rows. Okay, that usually happens. So once you are arranging the rows into the columns, columns are automatically arranged into the rows. So this is the transpose of a matrix. So now determinant of a matrix. So determinant of a matrix is nothing but transpose of cofactor matrix. So now we have seen the what do we mean by transpose, but what do we mean by cofactor? So now let us look at what we mean by cofactor matrix. So cofactor matrix. So now let us say that matrix only A, cofactor matrix of A. So what you need to do, cofactors means, first let me define that. So cofactors are found for the particular element. Cofactors are calculated for particular element. So now suppose if I wish to find cofactor for this particular position, what I need to do? So to take negative 1 and the power is the position in which row it is there and in which column it is. So you have this is first row and first column. So that's what I said initially. Having these positions is very convenient to do the matrix manipulations. Okay. So now you see this one I am taking and simply that is in the power of minus 1. So in order to find cofactor of this position, this is cofactor of A11, cofactor of the position A11. So now what we need to do, take minus 1 with power 1 plus 1 and leave that column and corresponding row and remaining whatever it is there. So you need to take it as a minus and write that. And of course here we have 2 by 2 matrix, it's easy. And if you go for 3 by 3, so we may have different minus. And even 4 by 4 we may have even difficult one. So now for this simply leave this first row and first column and write down. Okay, this is cofactor of the first position. Okay, and similarly, what about the cofactor of 2-1? Cofactor of A21? This one. Minus 1 power this. Second row, first column. Okay, and leaving this row and column remaining in this. Here. Okay. So now we find cofactor of all such positions, then take the transpose. Then you get the cofactor. Sorry. Cofactor matrix you make it, but that may not be the determinant. Oh, I'm sorry. So determinant is, of course, we can express in this way, but determinant is, this may be, this is inverse of the matrix A, and determinant is something nothing but this you need to add the cofactors. So that means for 2 by 2 matrix, sorry, it is product of diagonal elements and difference with product of non-diagonal elements. A11, A22 minus A21, A1. Sorry, sir. Determinant is nothing but it is a real number which is associated to a matrix. Okay, this is just a number. It's a real number associated with matrix. Associated with matrix. And this inverse of A, in order to find inverse of A, so you need to take 1 upon determinant of A times transpose of the cofactor. Inverse of matrix. So you need to divide with the determinant, then take the transpose of cofactor matrix. So cofactor matrix is calculated like this. So let me take one simple example. Cofactor of, let us take 1, 2, 3, 4. Okay. So now cofactor matrix means what you need to do. So for this position, minus 1 power 1 plus 1, leave this row and column in that form. And for this position, So the position is, it is there in the first row and second column, and leave this row and column, so remaining is 3. Okay. And similarly for this element, the position is, it is there in the second row and first column, and leave this row and column to get 2. And similarly for this element, so minus 1 power, it is there in the second row and second column, leave this row and column, remaining is 1. Okay, so that means we have here 4 and here negative 3 and here negative 2 and here positive. So this is the cofactor matrix. Okay. That is the cofactor matrix. So in order to find inverse, A inverse, so you need to take 1 upon determinant of A. So what is the determinant of this matrix? 1 upon determinant A times this transpose of cofactor matrix. Cofactor matrix transpose. So now 1 upon determinant. Determinant A means product of the diagonal elements in difference with non-diagonal elements products. So it is 1 into 4 minus 3 into 2 times transpose of this. So transpose of that is, so 1 into 4, 2 into 3 times transpose of this. So now take this row and arrange into columns. 4 minus 3, and take this row and arrange into the columns. So this is scalar, and you need to multiply inside. So that will give the inverse of the matrix. Okay. So that means, so here 4 minus 6 is minus 2, and here we need to multiply to each and every element here. So therefore we get negative 8, positive 4, and positive 6 and negative 8. So this is the inverse of that matrix. 1, 2, 3. So I hope I might have covered all possible terms which are mentioned in the matrix unit. So matrix definition, type of matrices, and possible operations on the matrices, determinant, inverse, and matrix multiplication. So now with this matrix multiplication is over. Now let me go to start with the limits. And if you can have any queries regarding this, you can ask it. I hope this will be clear to everyone.
We need some practice for this. After this it will be clear.
Okay.
But you can continue the limit.
So now, shall I move into the limits? So usually we discuss limit to the function. So I don't go in depth about what do we mean by function, and again I need to go to sets, and there you may have different kind of things. So simply I go in general. Okay. So what is limit of a function? Usually limit. So there is a situation. There are two things. One is depend on the another one. One is depend on the another one. That means one is dependent one and another one is independent one. So that dependent one depends on the independent one. Okay. So now the general situation. You have one independent one dependent one. So dependent one depends on the independent one. So now what this limit says, actually it is part of calculus. So limits is nothing but it is part of calculus. But what calculus does? It studies the changes in two things. Changes in the dependent thing when there is a change in the dependent thing. When there is a change in the independent thing. So like a simple example to take. So here the time is given to me from 3:30 to 4:30. Okay. So now if the time moves from 3:30 to 4:30, I will have 1 hour time. So therefore I should end my time. Okay. So that is limit to me. 1 hour duration is limit to me. I am dependent on time. I am dependent on time. So now I am dependent thing. Time is independent. Time is not depending on me. It is moving. I am dependent on that. So therefore, time moving from 3:30 to 4:30. So my duration of time is 1 hour. My limit is 1 hour. This is what we mean by limits. This is what we mean by limits. I mean, you have one dependent thing, one independent thing. Independent is something it changes, it varies. So now, based on that change, so what is the change you expect in the dependent? So now, is that dependent goes to infinite or does that goes to finite? So this is the matter. So for me, it is finite, but in all cases it may not be finite. Okay, it may not be finite. So therefore, this is what the limit comes. Limits in the sense. So there are two things. One is the independent one, and another one is the dependent one. So how the independent one changes? How dependent one changes based on the independent one. So therefore, that is what how we are going to study. So now, if it has some finite value, if it reaches some finite value, we say it is limit, and even infinite also doesn't matter at all. So now, let me take a simple example. F of x equals to x square. It is a function. So here, this is input. This is output. So I am not talking in terms of mathematics. So in general, so you are giving some input, you are getting out. X is independent one, f of x is dependent. So here x is independent one, and this f of x is dependent. F of x is dependent on x. Okay. So now what we need to find in order to study, okay, x is changing. X is changing. So what about f of x? This is the question. In order to study the limits, x is changing, x is varying. What about f of x? Where it goes? So if you can answer that, so you will get limit. Limit to what you get? Limit to the f of x. Limit of the function f of x. So therefore, now usually if we have function, okay, so where graph we take in the two dimension picture. That means we take x axis and y axis, and suppose if you wish to draw the take x1, usually we draw by taking the tabular form. Suppose if you take x and f of x, here usually we denote with y. If x is 1, y is 1. If x is 2, y is 4. X is 3, y is 9. So let me denote with some units. 1, 2, 3, 4. But I need only y more. So 2, 3, 4, 5, 6, 7, 8, 9. Oh, so 1 comma 1 is here, 2 comma 4 is there, and 3 comma 9 is somewhere. So I have this kind of curve. Okay. So f of x equals to x square is that curve. So if I connect all those points with smooth curves, smooth lines, So I get that. So this is graph of the function f of x equals to x. So now what we are studying about the limits. We are studying about the limits. So now let us say x is approaching let us say 2. X is approaching 2. What about f of x? What about f of x? Very good. That is the question. So if you can answer that, so f of x will have limit when x approaches 2. Okay. So when x approaches 2, so where f of x goes? So that is the limit. If it goes to the finite value, yes, it has limit. So wherever it goes, that number is nothing but limit. Okay. So now x is approaching 2. So how many approaches we have? 2 is there on the straight line. 2 is there on the straight line. So how many kinds of approaches we can have once we stand on the straight line? So I am standing on the straight line. Somebody wishes to approach me. Only through straight line. So in how many ways one can approach me when I stand on the straight line? Left hand and right hand. So therefore there are 2 kinds of approaches. So x can approach to from left hand side and x can approach to from right hand side. And for these 2 approaches, the dependent one f of x should reach only one value. So whatever the value it reaches, that is the limit. That is what I am saying. So now suppose if x is at 0, what about f of x where it is? At 0. If x is 0.5, so that means it is approaching 2, it is moving towards 2. It is moving towards 2 from left hand side of 2. So now if x is at 1, what about y? It will be there here, f of x. So now if x is moving here, f of x moves here. And if it is come closer, it goes closer there. And if it is very close to 2, it goes very close to this guy. Okay? So from left hand side. Suppose x is approaching 2 from right hand side. Okay? So now from right hand side. Suppose if x is there here, f of x will be there somewhere. It is moving and coming down. And if it is here, and this should be here. So it comes down. And if x is very close to this 2, and it comes down. Now you see, x is approaching from right hand side, but f of x is approaching this side. And if x is approaching from left hand side where up 2, f of x is also approaching this side. Okay? So now, whatever the approach it may be, either from right hand side or left hand side, it's reaching only 1. So that is the limit. So therefore, what is the limit of f of x? So what about f of x? Where it goes? It goes to 4. It reaches 4. It reaches 4. If x is approaching 2, f of x reaches 4. So therefore, limit of f of x is 4 when x is approaching 2. So usually in mathematical notation, we write limit x approaches 2, f of x approaches 4. This is the notation. This is the notation usually we write. Limit of f of x as x approaches 2, it is 4. It is not equal value. It is not equal value. So it is this notation, f of x approaches 4 as x approaches 2. So this is the notation we use. So limit of f of x is 4 as x approaches 2. So this is what do we mean by limit of a function. When we have a particular expression, so we can find like this. But in general is just to study. So when x is changing, once independently is changing, where that f of x goes. And usually all our actions have limits. Usually, in general. So whatever the course of action you are going to do, you have one limit. Okay. That may be the infinite, that may be the finite. It based on the person. It based on the person. I hope that is clear. So usually, if you have this kind of functions, it's easy. Okay. Suppose if I have f of x equals to x plus 1. If x is approaching 1, where f of x goes? So you are indirectly substituting actually. You are indirectly substituting x value 1. But it is in general it is not substitution. So here if you can substitute x equals to 2, what do you get? 4 you get. It is substitution. But when it comes to the limits, it is not substitution. It is approaches. It is approaching case. Okay, it is tending case. So that you need to keep in our mind always when you are talking about the limits. So now f of x equals to x plus 1. Suppose if x is approaching 1. What about f of x? Where it goes? It goes to 2. So simply substitute x equal to 1. It is possible to substitute. It is possible to get a finite value. So however you approach, it doesn't matter. You will get. So here if you can substitute 1 plus 1 is 2. Suppose if I have f of x equals to x square minus 1 divided by x minus. Okay. So now if x is approaching 1, that means here what we write? Limit x goes to 1, f of x is 2. So now clearly I am asking for this. Limit x goes to 1, what about f of x? So what I said, for usually for this as well as this example, you can simply substitute x equals to 1. You will get the value. It doesn't matter at all. You will get the value. But for that example, substitute x equals to 1. So you get 1 square is 1 minus 1 0 divided by 0. So it is indeterminate form. Usually there is no determinate value for that expression 0 by 0. We say it is indeterminate form. Okay, but when x is approaching 1, you put the value. So that means you put 0.000. 1 means you substitute x is approaching 1 means from the left hand side you have 0.999 and how many lines you take, doesn't matter at all. So you substitute it. You will not get 0 by 0 form. You will not get 0 by 0 form. Substitute and calculate, you will not get 0 by 0. And similarly, suppose from the right hand side, if you can substitute 1.000001. Okay? So that is the right hand side value of 1. Okay? 1.001 is the right hand side values of 1. And this 0.999 is the left hand side value of 1. Okay? So that means x is approaching from left hand side and x is approaching from right hand side. Suppose if you can substitute this value in this, you will not get 0 by 0. So you will get closer to 2. You will get 1.999 something. So you can calculate 1.9999 something. And even what is also you get that 1 point. Okay. You will get around 2.00000 like this. And with what confidence I am saying that because it can be simplified. It can be simplified. So when you can simplify this, you will get a simple expression. So you will get this. I mean, x square plus 1, you can write it as x minus 1 into x plus 1. X minus 1 gets the answer. You will get expression. That's what I am saying. So with what confidence I am saying that because of this, it is same. These both are same. These both are same example, but only one thing what I am doing, I am expressing in a different way. I am trying to express this in a different way. Okay? For me it's easy to calculate, simplify, factorize, then cancel out. So I can get. But in general it may not be possible always. Okay, so therefore, what we need to think is only the approaching case we need to keep in our mind. Limits means approaches. Limits means approaches. I hope that is clear. Shall I move to the differentiability? Ma'am, shall I move to the differentiability? It's my time. Differentiability. Just I will give the geometrical interpretation. I will not go further, so I can complete it. So I may take hardly another 5 to 10 minutes. Okay, let me go to this one. Usually for this we have a mathematical expression. So that expression is very hard. It's very difficult to understand, and still even our mathematics students also gets confused. There is a data echelon definition to understand this. So, but this is a general overall view. I am not going to give the mathematical expression definition. Okay. So now differentiation of the function. So now this is also again studies the changes. It is also a limit. So what kind of limits it is? It looks at the changes in the f of x with respect to the change in the x again. But whereas here only x changes, how f of x changes. It is a limit. But when it comes to the differentiability, it looks at the difference, change difference. I mean, suppose if I have y equals to f of x. So if there is a change in the x, so here I have x. So if there is a change in x, let us say x plus delta x. X plus delta x. So now how it changes? So that means for x value I have here f of x. This point is nothing but x comma f of x. This is x plus delta x. Delta x is very small quantity. So I have here. So this is x plus delta x and f of x plus delta x. Okay. So now once you connect these 2 points, so you may get a secant line. So once you connect those 2 points, you may get one secant line. Connecting those 2 points, one straight line if you can draw, so that we call it as a secant line. So we have one secant line. So now what this differentiation does? So now you have a change in the x, so automatically you expect change in the f of x. This is a change in the f of x. When there is a change in the x, when there is a small change in the independent variable, there is some change in the dependent variable. So that small change is nothing but delta x. So here small change is nothing but delta x. Okay, so there is a small change in the x, and there is automatically change in the f of x, the dependent variable, in the dependent variable. So that is this. So now, what about the total change in the f of x with respect to change in the x? So that means you need to subtract f of x. Okay, so you have change in the dependent variable x, f of x plus delta x, and already you have f of x. So the difference will get. Okay. So now how this difference changes with respect to this change? That's what the differentiation. Okay. So now suppose if I take limit as delta x goes to 0. Okay. So now here what is the margin that we expect delta x is changing to the delta x. Okay. So now if I take delta x goes to 0, what about x plus delta x where it goes? If delta x is tending to 0, where the change, that small change, x plus delta x, where it goes? So this is tending to 0, means automatically x plus delta x tends to x. That small change, whatever we have assumed, If it is tending to 0, that means you are expecting there is something change, but that change is nothing. That change is nothing. It is moving towards to 0. So what about f of x? Okay. So now see here, this express delta x tends to x. That means it is coming towards to x. This express delta x can be here, and you can also take the left hand side x minus delta x, doesn't matter. So now, if it is coming towards this, how this line changes? That we need to observe. That is the differentiation. Okay. So now, suppose if express delta x comes here. Okay. So automatically, where this express delta x and f of x delta x comes, it comes here. That means this straight line, it is becoming like this. Okay. And of course, if it is comes very closer to x, what about this straight line? It comes towards to this point, and totally it becomes this line. So at this point only it matters. So that becomes tangent at that point. Okay, so whatever the secant line we have taken with 2 points, when the delta x goes to 0, x plus delta x goes to x, x plus delta x comes towards to x. When it comes towards to x, at that particular point, so it will become tangent. So therefore, now if this exists, so we say it is differentiation of f of x. This is what is the differentiation. Okay. It is also limit. It is also approaching case. But it is rate of change. So how this change is happening with respect to the change in this. So how we are getting this x plus delta x? It is x plus delta x minus x. Actually, it is the change. It is x. It is the change in the f of x. We are taking f of x. So just take the change in the f of x with respect to the change in the x. Okay. If the change is going towards to 0, that means if change is very small, so automatically we get rate of change. So that rate of change is nothing but differentiation. And to discuss the differentiability, it is a limit. So therefore, once you know the limits, then only you can have the differentiation. If you don't know the limits, you cannot find out the differentiation. And of course, you can remember the formulas, but without knowing limits, you cannot discuss the differentiability. Because differentiability is also kind of. So therefore, this is differentiation. And the types of differentiation is nothing but simply if you have two functions f of x and g of x, if you can differentiate it, okay, it is term-wise differentiation. It is term-wise differentiation. Okay. Change, if you want to look at the rate of change, look at the sum of the individual rate of changes. Okay. If you want to look at the change in the sum of the two functions, look at the rate of change, sum of the rate of individual changes. And similarly, if you have negative subtraction, you get the expression. But only for product there is a change. For product there is a change. So it is, you need to take one thing same and differentiate the another thing. And in other next term, look at the change, the rate of change in the first one, and keep second thing as it is. So these are the operations on the differentiation. So I hope I might have covered overall in brief those two concepts without any example. For these limits, okay, limits I might have written. So here for the differentiability you need to know limits. Without knowing limits we cannot do the examples on the differential. And if you can have any queries, you can ask me. Thank you so much.
ಧನ್ಯವಾದಗಳು. ಪರ್ವತಲುಗೆ ಗೋಷ್ಠಿ ಅಧ್ಯಕ್ಷತೆ ವಹಿಸಿರುವಂಥ ಸುರೇಶ್ ಅವರು
ಒಂದು ಗೋಷ್ಠಿಯ ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಯಾದ ಡಾಕ್ಟರ್ ಬಿ ಪಾರ್ವತಲು ಸರ್ ಅವರೇ, ನನ್ನ ಆತ್ಮೀಯ ಎಲ್ಲ ಶಿಕ್ಷಕ ಬಂಧುಗಳೇ, ಇವತ್ತಿನ ದಿನ ಈಗಾಗಲೇ 4ನೇ ದಿನ. ನಾವು 3 ದಿನ ಅನೇಕ ವಿಷಯಗಳನ್ನು ಇಲ್ಲಿ ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ವಿ. ಆದರೆ 4ನೇ ದಿನದ ವಿಷಯ ವಸ್ತು ಏನಿತ್ತು ಅಂದ್ರೆ ಮ್ಯಾಟ್ರಿಕ್ಸ್, ಲಿಮಿಟ್ಸ್ ಅಂಡ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್. ಇದು ಹೊಸ ಕಾನ್ಸೆಪ್ಟ್ ಆಗಿತ್ತು. ಫಸ್ಟ್ 3 ಡೇಸ್ ಏನಿತ್ತು, ಈಗಾಗಲೇ ನಾವು CBCS, ನಾನ್ CBCS, ನಾನ್ CBCS ನಲ್ಲಿ 3rd ಸೆಮಿಸ್ಟರ್ ನಲ್ಲಿ ಫಸ್ಟ್ 2 ಟಾಪಿಕ್ಸ್ ನಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕವರ್ ಆಗಿತ್ತು. CBCS ನಲ್ಲಿ ಅದರಲ್ಲೂ ಫಸ್ಟ್ 2 ಟಾಪಿಕ್ಸ್ ನಲ್ಲಿ ಅವೆಲ್ಲ ಬಂದು ಹೋಗಿತ್ತು. ಅದರಲ್ಲಿ ಇನ್ಕ್ಲೂಡಿಂಗ್ ಇಂಪಾರ್ಟೆನ್ಸ್ ಆಫ್ ದಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್, ರೋಲ್ ಆಫ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್, ನೇಚರ್ ಅಂಡ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಆಫ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್, ಎಕನಾಮಿಕ್ಸ್ ಅದು ಬಂದಿತ್ತು. ಆನಂತರ ಇಂಟ್ರೆಸ್ಟ್, ಸಿಂಪಲ್ ಇಂಟ್ರೆಸ್ಟ್, ಕಾಂಪೌಂಡ್ ಇಂಟ್ರೆಸ್ಟ್ ಅದನ್ನು ನಾವು ಅಧ್ಯಯನ ಮಾಡಿದ್ವಿ. ಫಂಕ್ಷನ್ ಅಧ್ಯಯನ ಮಾಡಿದ್ವಿ. ಅವು ಎಲ್ಲ ಆಗಲೇ ನಾವು ಒಂದು ಸೆಮಿಸ್ಟರ್ 2 ಸೆಮಿಸ್ಟರ್ ನಲ್ಲಿ ಅವುಗಳನ್ನು ಮುಗಿಸಿದ್ವಿ. ಈಗ ಇವು 2 ಯೂನಿಟ್ ಇದೆ, ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಮತ್ತೊಂದು ಲಿಮಿಟ್ಸ್. ಯೂನಿವರ್ಸಿಟಿ ಇದು 10 ತಾಸಿನಲ್ಲಿ ಈ ಒಂದು ಕ್ವಶನ್ ಅನ್ನು ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಪಾಠ ಮಾಡಬೇಕು ಅನ್ಕೊಂಡ್ಕೊಂಡಿದ್ದಾರೆ ವಿತಿನ್ ಅವರ್ ನಲ್ಲಿ. ಇವತ್ತು ನಮ್ಮ ಮುಂದೆ ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಗಳಾದ ಪಾರ್ವತಲು ಸರ್ ಅವರು ನಮಗೆ ಹೆಚ್ಚಿನ ಮಾಹಿತಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಆದ್ರೆ ನಮಗೆ ಸ್ವಲ್ಪ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಬೇಸ್ ನಾವು SLC ಹಂತದಲ್ಲಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅನ್ನು ನಾವು ಬಿಟ್ಟಿರೋದ್ರಿಂದ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಬೇಸ್ ನಮಗೆ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಆ ವಿಷಯವನ್ನು ನಾವು ಗ್ರಹಿಸಲಿಕ್ಕೆ ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗ್ತಾ ಇದೆ. ಆದ್ರೆ ನಮಗೆ ಅಷ್ಟು ಕಷ್ಟ ಅನಿಸ್ಲಿಲ್ಲ. ಅದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಏನು ಹೇಳಿದ್ರಲ್ಲ, ನಾವೇನು ಸೆಟ್ ಥಿಯರಿ ಓದ್ತಾ ಇದ್ದೀವಲ್ಲ, ಸೆಟ್ ಥಿಯರಿಯಲ್ಲಿ ಅದೇ ಮಾಡೆಲ್ ನಲ್ಲಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಥಿಯರಿ ಬರುತ್ತೆ ಎಂಬುದಾಗಿ ನಾನು ಅನ್ಕೊಂಡೆ. ಹಾಗಾಗಿ ಇಂದಿನ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವು ಸಹಿತ ಅದ್ಭುತವಾಗಿ ಮೂಡಿ ಬಂತು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಈ ಸಂದರ್ಭದಲ್ಲಿ ಈ ಸಂಘಟಕರಿಗೆ ಮತ್ತೊಮ್ಮೆ ನಾನು ವಂದನೆಗಳನ್ನು ಹೇಳ್ತಾ ನನ್ನ ಅಧ್ಯಕ್ಷೀಯ ನುಡಿಗಳನ್ನು ಮುಗಿಸ್ತೇನೆ.
ನಾನು ನಿಮಗೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲೇ ಸೆಷನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕಂತ ಹೇಳಿದೆ. ನಮ್ಮ ಇಂಟೆನ್ಷನ್ ಇವತ್ತಿರೋದು ಆ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಏನಿದೆ ಅದು ನಮಗೆ ಗೊತ್ತಾಗಲಿ ಅಂತ ಅನ್ನೋದಕ್ಕೆ. ಈಸ್ ಫ್ರಮ್ ಟಿಪಿಕಲಿ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಬ್ಯಾಕ್ಗ್ರೌಂಡ್. ಅವೆಲ್ಲ ನೊಟೇಷನ್ಸು, ಅವೇ ಟರ್ಮಿನಾಲಜೀಸ್ ಇದ್ದಾವೆ. ಆ ಟರ್ಮಿನಾಲಜೀಸ್ ಮೇಲೆ ಮೇಲೆ ಬಿಲ್ಡ್ ಅಂತ ಅನ್ನೋದಕ್ಕೆ ನಾವು ಅದನ್ನು ತಗೊಳ್ತೀವಿ. ಇದನ್ನ ಪ್ರಾಕ್ಟಿಕಲಿ ನಾಳೆ ಸಂತೋಷ ಒಂದ್ಸಲಿ ಮುಗಿಸ್ಕೋಬೇಕು. ಅವಾಗ ಅದು ಈಗ ಅದು ಥಿಯರಿಟಿಕಲ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸು, ಅದು ಎಕನಾಮಿಕ್ಸ್ ಅಪ್ಲೈಡ್ ಹೆಂಗೆ ಬರ್ತದೆ ಅವಾಗ ಈಸಿಲಿ ವಿ ಕ್ಯಾನ್ ಕ್ಲಾಸ್. ಈಗ ಬಾಯಲ್ಲಿ ಟರ್ಮ್ಸ್ ಆದ್ರೂ ಗೊತ್ತಾಗ, ಅವು ಬಳಸೋದಾದ್ರೂ ಗೊತ್ತಾಯ್ತು. ಅಟ್ಲೀಸ್ಟ್ ಫಾರ್ ದ್ಯಾಟ್ ಥಿಂಗ್ ಡೆಫಿನೆಟ್ಲಿ ಐ ಆಮ್ ಕ್ವೈಟ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್ ವಿತ್ ಪರ್ವತಾಲು. ಈಗ ಈ ಇಂಟೆನ್ಷನ್ ಗೊತ್ತಾದಾಗ ನಾವು ಹೇಳ್ತೀವಿ ಏನೋ ಹೋಗ್ತಾ ಇದೆ. ದಟ್ಸ್ ವೈ ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಎಕ್ಸಾಂಪಲ್ಸು ಅವಾಯ್ಡ್ ಮಾಡಿಸಿದ್ದೀನಿ. ಎಕ್ಸಾಂಪಲ್ಸ್ ಪರ್ಪಸ್ಲಿ ತಗೊಂಡಿಲ್ಲ. ನಿಮಗೆ ಎಷ್ಟು ಹಾರ್ಡ್ ಟಾಸ್ಕ್ ಅಂತ ಇವಾಗ ಫಾರ್ಮುಲಾ ಕೇಳಿದಾಗ ಅನಿಸಿದೆಯಲ್ಲ, ನಾಳೆ ಪ್ರಾಕ್ಟಿಕಲ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಸಂತೋಷ್ ತಗೊಂಡಾಗ ವಿಲ್ ಫೈಂಡ್ ಇಟ್ ವೆರಿ ಮಚ್ ಈಸಿ. ಓಕೆ, ಇವತ್ತಿನ ಈ ಸೆಷನ್ ಅಲ್ಲೇ ನಾವು ಟೀ ಕುಡಿದು ಇವತ್ತೇ ಕ್ಲೋಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಯಾಕಂದ್ರೆ ಬಹಳ ಸಲ ಕುರ್ಸಿ ಲಗ್ನ ಇದೆ, ಹಾಗಿದೆ ಏನಿದೆ ಬೇಗ ಹೋಗ್ತಾ ಇದ್ದೀರಿ. ಸೊ ಟುಮಾರೋ ಬೈ 12 o'clock we will have the session. By 1 o'clock we will have the validation. Just wait for 2 minutes.
ಅಲ್ಲ ದೋಷಿ ಬಂದಿದ್ದು ಹೇಳ್ಬಿಟ್ಟು ಹೊರಟು